Thank you for waiting, everyone. Good afternoon, everyone, and thank you for joining us for today's third RE Tech Talk. I'm Lakshmi Bohra, your host, and I welcome you all to our third RE Tech Talk, where we will talk about building integrated photovoltaic. This webinar is being organized as part of the collaboration between BIPV, a project on the integration of renewable energy in buildings, implemented by IIEC and supported by Swiss Agency for Development and Corporation. And we have partnered with U Solar Clean Energy Solution for the talk series. In this series, we will be exploring a variety of topics related to implementation of renewable energy projects in building with our expert speakers. The talk series began on 17th February. However, if you were not able to attend, you can find the link on the recordings on your mail. Please mark your calendars for these webinars. We will also be sending out reminders and updates to all registered attendees. A quick recap on the last RE Tech Talk, where Ninad explained different ways in which solar PVs are installed based on various parameters. Our goal is to give you essential knowledge and information about RE technologies and their application through our highly qualified speakers who are excited about imparting it to you. Before I invite our speakers, I would like to run you through the GoToWebinar interface we are using for this webinar. For the entire duration of the webinar, your microphones will be on mute and webcams will be turned off by default to avoid any accidental background disturbance. During the webinar, if you have any questions or comment, please share the same using the questions or chat options available in the panel at the right side of your screen. We will take the questions at the end of the two sessions. You can also access the additional informative material in the handout section. Please note that this webinar is being recorded and the recordings will be made available in the public domain. Thank you for your patience. Without holding you any further, I will invite our first speaker, Ms. Sonia Shukla, Senior Project Manager, International Institute for Energy Conservation, IIEC, for sharing the opening remarks and setting the context for today's talk. A bit of background about Sonia. She has more than 12 years of experience and has worked on in the fields of energy efficiency, renewable energy, electric vehicles, and clean air. She oversees the team at IIEC and works on the sustainable energy field. Sonia, the mic is yours.
Perfect. Thank you, Lakshmi. Thank you for the introduction. Let me just walk you through today's discussion session, the plan, and what are we aiming to achieve. So before that, I would just like to introduce our organizations a bit. IIEC, International Institute for Energy Conservation, is a non-governmental, not-for-profit organization. We were established to foster the implementation of renewable energy and energy efficiency in developing countries and economies in transition. And in India, we are registered as a Section 25 company. We work across various sectors, but with the common agenda of sustainable development and resource conservation. We largely work with the government, private sector, multilaterals, donor organizations, and philanthropies. And for today's discussion, I would just like to mention the project that we are doing. It's approximately 5 years long work that we have been doing with the Swiss Agency for Development and Cooperation. This work is called BIPV, and it aims to develop solutions for holistic integration of renewable energy technology in the building sector. This program has was started in January 2019 and has achieved substantial outcomes. We have fostered collaborations with private sector, public sector, and have serious engagements with several stakeholders to demonstrate technological interventions, identify specific technologies which are applicable for built environment, and we have been lucky and fortunate enough to work with the big names in the sector and have actually started and supported them in implementation of these technology options that were identified for them. Apart from this, we have also developed tools and manuals to assess the RE potential and the fact sheets for various renewable energy technologies, which are available on our webpage and are probably also available in the handouts section. We will also later on share the link of the page and the session today. We are in process of developing learning modules, self-learning modules, which will help in developing better capacity of designers, architects, and planners at the design stage to understand, evaluate, and assess renewable energy technologies which are appropriate for their own designs and buildings. With this, we are going to discuss today a bit more about BIPV, and we'll have Mr. Akshay from USolar discuss this in a lot more detail and walk us through the entire process of technology integration as well, part of it, and I hope this would be useful for everyone. And if you have any questions, please do come back to us, write to us, and we can have an interactive session today. With this, I give you back the mic, Lakshmi. Thank you so much.
Thank you, Sonia, for setting the context of the overall presentation today. Now we will move on to the speaker of the day, Mr. Akshay MG, Technical Consultant, USolar, to present the BIPV system in the first session. A brief background on Akshay. He is a highly proficient technical consultant at USolar Clean Energy and has extensive knowledge and experience, primarily specializing in pre-sales, designing, and client interface to attain sustainable objectives. For the presentation, we will share the controls of the PPT with you, Akshay, in the next few moments. I request everyone to write their questions in the question tab as the presentation goes along. Questions will be taken twice, after the first and the last session. Akshay, I think we are having some issue with sharing the controls. You can just let me know when I have to change the slide. Is that all right?
Yeah, sure.
You can see the screen, right? You can see your presentation screen.
Yeah, I'm able to look at the screen.
Yeah, okay. Please let me know when I have to change the slide.
Yeah, sure. I can start, right? Hello, good afternoon, everyone. Thank you, Ms. Sonia and Lakshmi, for the introduction. Myself, Mr. Akshay MG from USolar. I'm working here as a technical consultant. I joined USolar back in August 2022, and I look into pre-sales design and sales part of the solar. Can you please move the slide? Yeah. About USolar. USolar is a developer and EPC company, means engineering, procurement, and construction company, which is headquartered in Bangalore, St. Mark's Road, and we provide the solutions for industrial, commercial, and institutional and residential clients. USolar started its operation back in 2010, and we have experience of more than 12 years. We design and develop the solutions ranging from residential to utility scale solar power plants, and we have executed more than 250 plus projects and 170 megawatt peak of install. We have 170 megawatt peak of installed capacity. We have operations across pan India, and we have projects in Nepal also, and we are looking to expand overseas in the coming days. And we offer the projects such as capex, which is the direct investment from, means own investment from the clients. Opex, in this we do the investments, and client needs to pay the tariff as agreed, like we develop the project for the clients, and they just need to pay the as per the generated electricity. And we do total EPC solutions, asset management, and we have in-house O&M also. Like we offer the solutions across solar rooftop and ground mount BIPV solutions, battery storage systems, and carports. Next. Yeah, today the topic is regarding the BIPV systems. BIPV system means like the panel which we directly mm, integrate into the building. Material used to replace the conventional building material in architect elements of the building, and we can integrate the like modules to the building where the glass normal facade glasses will be placed, so that the it will be having the higher commercial values to the building, and the building can generate its own electricity. Next slide. In BIPV system, it includes the main component has a PV module, which is a customized module as per the requirement of the building, or as per the building requirement, and it will be having the inverters. Here we have to use the inverters with optimizers, or the micro inverters, and it comes up, and all the other things will be same what we do in the rooftop solar or the other utility scale solar. Only change here is that we have to the selection of inverters should be like solar inverters with optimizers, and the micro inverters to increase the efficiency of that plant. And we can also have the battery power systems, and it will be optional thing. Next slide. As I was talking regarding the inverters, we have to we need to use here the string inverters with optimizers or the micro inverters, because in what happens is in string inverters uh, we can't get that generation with in BIPV, because in string inverters if there is a shadow or any other problem, the whole string will get affected and there won't be any generation. In with respect to the string inverter with optimizers, it reduces the risk. It reduces that risk of the failure of that string, and it optimizes the current, and we can get the maximum output from that string or from that module. And in micro inverters, it directly converts from the module to AC, so that there won't be any effect from the string as and when as with the string inverters. Can you please next slide? And why we have to use the optimizers, have some points, like in real case scenarios, the it will be first is partial shading, the modules will be having the shading from the nearby objects. In case of BIPV, today there won't be any building next to the installed BIPV. In future, it might come. Like we don't. In future, it might come. Today there might be any losses, but tomorrow when the building comes, and if there's any shadow problem, means the whole string or the power generation of power will get affected. And the soiling mismatches is, soiling losses here means the dust or the dust to the small thing like bird droppings also reduces if in one string, if there is a most of the soiling losses and the bird droppings, means it affects the whole string, whole string, and there won't be any generation. For example, because of the soiling losses, in BIPV thing, we have selected the 440 watt peak modules, and the power generation is only with respect to 240, and 240 in one string there will be around 18 to 20 modules, and if one module in the string is generating the 245, means every other modules will match to that, because the string inverters will be having a MPPT, maximum power point tracking system. It's a software which recognizes the least generating power and matches to that, so there will be higher losses. In this power optimizer, it don't happen like that. There will be 2:1 power for every two module. There will be one optimizer. So if there is less than if in one module, if there is 245 and another is generating around a higher capacity due to some soiling losses or the bird droppings or any other shadow thing, it will take 245 and the higher capacity, so it won't affect the whole string part. So can you please next slide? And dynamic changes, the fast changing climate and changing light, like cloud, or if there's due to the weather fluctuations, we can see in some of the areas or the cities, like there will be morning it will be cloudy and it will be sunny. This affects the power generation affects this also, like, and there will temperature differences. The temperature differences is in one module it will be like higher temperature due to the ventilation problems. In BIP we have to give the correct ventilation, and BIP facades will be of the BIP facades will be of the like a customized thing. So if we give all the things like the ventilation and all, it won't affect much with respect to temperature losses and all. Next slide. Even under the perfect conditions, like the no near shading losses or the soiling losses, and it's for performing completely all right in perfect condition, means in while manufacturing the PV modules in the same batch, when we get, there will be power tolerances of plus or minus 2 or plus or minus 3%. In that also, there will be a significant energy loss, about 2%. Even this can be corrected by the optimizers. And even if we have all the above 5 thing in a perfect condition, there is something called the aging mismatch as an effect of time. The module manufacturers will give the degradation as for example, if we take the monocrystalline module, means the monocrystalline modules, first year the degradation will be around 2%, and the year on year it will be 0.55%. In same batch, it might vary. There might be a perfect degradation of 0.55%, and other modules will be having the 0.4 and 0.6%. This thing will affect most this degradation loss or the aging mismatch loss will affect the generation in the long run. This might be a lesser thing in the in the initial years, but it will be more like if we take the thing at if we consider the thing at the 20th year, it will be more mismatch losses. Next slide. So steps in designing the BIPV. In first step, what we do is the BIPV architecture. We closely work with the BIP design consultation and working close with the architects to get the possible that design that meets the vision and needs what the company is looking for. And we will look and this BIPV needs to be integrated with the facade thing. We closely work with the architects how this needs to be designed in the initial stages, and technical evaluation will be done. We do the BIPV layouts and the technology selection, the modules, the color of modules or the power output, the wattage of the modules, and the the inverter selections and the facade thing. And we do the comparative assessment by comparing the on the cost basis and the efficiency with respect to modules and the other technically selected components. Next one. The potential, India's PV potential, like the potential is calculated by the MNRE, means Ministry of New and Renewable Energy, in states like Rajasthan, Jammu and Kashmir, Maharashtra, Madhya Pradesh. They constitute around 50% of the total PV potential in India. And in Punjab, Karnataka, Tamil Nadu have utilized more than 20% of the PV potential. And India is the fifth country in terms of installed capacity, with the target of 300 gigawatt by 2023. We post to make a big impact in the global market. Next. This is the PV map, PV potential map of India. You can see that where the places, for example, the places which are marked in like a yellow will be having the potential of around 1400 kilowatt hour per kilowatt peak per year. And when we go on the like upper Gujarat side and all, it's have potential of around 1700 to 1800. It differs across the region. Next slide. And USolar is aggregated installers for on-site solar modules in India, and on-site and Renewables Solar. And we have non-binding partnerships with the all module manufacturers, and we use only the tier 1 modules. And quality and safety is the priority. In previous projects, we have achieved a zero incident while doing the INC, and quality O&M also. This is the BIP project which we have installed in the Mumbai for controls data center. The total capacity is 863 kilowatt peak. We have installed vertically all across all 4 sites. The orientation is 551 and 312 kilowatt peak. The total number of modules what we have used is 2466, and with 350 watt peak modules, Vari modules. And we have used the Solar Edge inverters with optimizers. 9 inverters we have used, and all the customized DI frame facade frames. To install the BIPV modules, we need to have the customized facade, customized aluminum rails or glass facade to mount the structures. And it will be like aluminum rails. So the panels will be connected as they are placed on the structure, and electrical work and can be done simultaneously. Next. Uh, the in project deliverables, the challenges what we face is like, as you know, in solar modules we need a specific orientation, and the optimum orientation is the south orientation, and to place it along with the latitude degree angle, so that it will be having the maximum energy yield. Since the building will be in the vertical, it won't be having the optimum generation has when compared to the rooftop or the utility ground mount solars. For example, if the rooftop or ground mount solars will be having a yield of, for example, 1400 kilowatt hour per kilowatt peak per year, means in BIPV in the same region we can expect around 700 or 750 kilowatt hour per kilowatt peak per year. Uh, this is the one drawback with respect to the BIPV. We can't say this drawback anyhow. It will be having the commercial value. It adds the commercial value to the building. The solution, the entire building on four sides. So when we use the power optimizers or the micro inverters, there will be higher generation than the string inverters. Next slide. The main advantages of the BU modules or BIPV modules, or the BIPV will be visually appealing and blend well with the building structure. It's really tough to make out that we have installed the solar modules, and it feels like the natural glass, and it looks like the ordinary what will be the what it will be installed across the industries. And the BIPV modules, when replacing the walls, provides active noise cancellation thing, and it reduces the energy consumption of the building and reduces the HVAC loads, and it also increases the building's valuation and the prestige, and it, like commercial value, it increases the commercial value also. Next slide. BIPV SWOT analysis. In SWOT analysis, the strength of this is higher solar attractiveness, lower LCOE, and like consumer attractiveness with the net metering. And now government across the world is coming up with the net zero building, and government is taking the initiative to integrate the solar to the building so that it can have a net zero and zero carbon footprint. In like in China, like they had made a policy in some provinces that some of the new building which they are coming up with, they need to have with the BIPV. Like weakness of this BIPV is there are only limited number of manufacturers in India, and the very less awareness, and there is no specific policy with respect to BIPV from central or the state governments, and there is very less number of BIPV projects in India. And the threats with respect to BIPV projects is and there is lack of coordination and awareness, leading to the uninspired project demonstrations and elevating import duty. Here in India, there is very less BIPV modules manufacturers, and it has to be customized, and it's the module price is on the higher side, but like India has come up with the LLM thing, where to have the open access or the net metering, need to install only the Indian manufactured modules. So in China, like or foreign countries, there is a BIPV. They are adopted in larger scale and they are growing year on year more than us. And from foreign, we can import it for a lesser cost, but the policies is not that friendly to have. And operation maintenance is of like the operation maintenance of the BIPV buildings is a little bit more expensive and tough than the rooftop solar and the ground mount thing. It needs a specialized technicians to do the O&M. Like opportunities with respect to BIPVs, prefabricated and cost-effective construction. It's a disruptive technology like uh, can generate our own electricity in the building, and India is growing at a faster pace, and growth of Indian building construction sector also. Next. The future of urban energy in net zero buildings. 100% energy efficient sustainable buildings have lower energy demand than that of conventional buildings and produce at least as much as they consume in a year throughout the on-site renewable energy technologies. And it is highly recommended for the net zero energy building should be planned to harness the maximum solar potential using the building envelopes. Next slide. Yeah.
Thank you, Akshay, for the first session. Before we move on to the second session, I would like to take up one question asked by Ramesh. He has asked, hardly seeing any BIPV in Indian buildings. Is there
Okay.
any constraints in installing it? Also, will it be financially wise to prefer BIPV over rooftop or ground-mounted solar?
Okay. The first question is there any building, right? Is there
Is
any
hardly seeing any BIPV. Is there any constraint in installing it?
Yeah, now the people are coming with the BIP thing, and we have installed in the Mumbai Data Control Center of 800 kilowatt peak. The constraint is like the awareness the people having. It's just awareness. Like it has not that much spread like the rooftop or the ground mount solar.
And the next part of the question was, will it be financially wise to prefer BIPV over rooftop or ground-mounted solar?
Yeah, here like in normal building we just install the glass panels which don't have any commercial values, like we don't generate anything. In BIPV, it will act as like the glass also, and it generates the electricity which has a commercial value. Like in play, for example, it don't generate much electricity as the rooftop or the ground mount, but it generates like 700 or 750. For example, in some states like in Karnataka, Maharashtra, if we take, it will produce around 750 kilowatt hour per kilowatt peak per year.
Okay.
And
Before we
it
move,
has payback year of like 8 to 10 years. Like in general, a rooftop and ground mount will be having like 3 to 5 years, but in this it's on the higher side, like 8 to 10 years.
okay, before we move on to the next session, which is on the
Okay.
shortlisting of technologies, I would again try to give you the controls to move through the slides. Could you just check once?
No, just I can move the cursor over here.
Now?
No,
Okay, I
I'm
will
not
do
able.
the. It's okay, I will do the controls. Okay, just
Okay.
let me know. You could continue now.
Yeah. 1 minute. Can I have 5 minutes? 1 minute. Can I have water?
Yeah, sure, please, please.
Just a minute.
We will be back in the session in like 2 minutes. Please stay online.
Okay. Shall I continue?
Yeah,
Hello.
please.
Have you given me the controls?
Yes, I have.
No, but minimize this.
If it's not possible, then I will be helping you with this.
Okay, sure.
Oh.
Yeah. Yeah. Shall I start, right?
Yes, you can go ahead.
Yeah. This session will be regarding the shortlisting of technologies and the integration type. Here, the common uh, thing in solar is the solar rooftop system, which can be installed on the shaded roof or the RCC roof on top of any institutions, residential or commercials. And the ground mount thing, in ground mount, we can have open access group captive and captive thing. Like building integrated system is a BIPV, which can be vertically integrated to the buildings. Solar plus storage. This in this system it comes like off grid and hybrid. Solar storage will be bigger thing in near future, like solar carport systems and floating systems. Next slide. The main components of the solar is the modules and inverters. Inverters will constitute around 60-65% of the solar system, and inverter constitutes around 5 to 10%. These are like heart and brain of the system. Next one. In solar modules, we have different types, like polycrystalline modules, monocrystalline. In monocrystalline we have monoperc and monocrystalline off-cut cells, and bifacial. In uh, bifacial we have the solar PV on both the sides, which increases the capacity by around 20 to 30%. And the difference between the poly and the mono is the efficiency. And main thing, the poly is from the multicrystalline, the multiple solar wafers, and the mono is a single thing, which increases the efficiency. The typical monocrystalline or monoperc efficiency is around India is around 90.6 90 sorry 20.98%, and poly is around 16 to 17% efficiency. Can you please next slide? Yeah, the efficiency differs across the module technology. Like poly is the least thing, and the mono is will be on the higher side. The poly is having the will be having around 16 to 17%, and the module standard rated capacities in the market is 330, 335 watt peak and 390 watt peak, and mono comes around like 440, 540 and 600, 640, and it's the numbers are just growing on with the R&D. Like monocrystalline and monoperk efficiency comes around 20.5 to 21, 22.5 also with some of the foreign modules. The degradation rate in the poly modules is around 2.5% the first year, and it degrades around 0.6 year on year till 25 years. In mono modules, it degrades 2 years on the end of first year, and 0.55 year on year till 27 years. Durability of panels in poly, they give the poly comes around 10 years product warranty and 25 years performance warranty, and mono comes around 12 years product warranty and 27 or 30 years performance warranty. Next slide. Inverters, the different types of inverters are string inverters, micro inverters, central inverters. String inverters will be mainly used on rooftop solars, residentials, and some of the main commercial projects. Micro inverters is something we directly connected to the modules. Micro inverters we directly connect with modules. It's 1:1, which directly converts from DC to AC. The micro inverters will mainly used on the residential and small commercial. Central, when we come to central inverters, it will be of the utility scale solar. Next. Yeah, the inverter size, in string inverters, we can have the size from 1 kilowatt to like 100 kilowatt or 100 kilowatt in LT lines, and in HT we can have around 200 to 95 kilowatt of inverters, and in micro inverters comes around like it's 1:1. When we have 540 watt peak to the 5, we can integrate the micro inverters to 540 or 440 watt with direct connection to the modules, and central inverters come from like 5 megawatt, 5 megawatt, and now the technology has evolved in such a way that now we are getting the central inverters of 1.1 megawatt also, and it can be clubbed together and made it to like 10 or so, and applications of inverters like string inverters, we mainly use it for like residence, commercial and industrial, which is rooftop solars, and micro inverters we mainly use it for the residential part, and the central inverters will be mainly for the utility scale. The cost of ownership, like the string inverters, when compared with the micro inverters, string inverter will be of a less cost, and even for the utility scale, for megawatt scale, we can use the string inverter which comes up in HT, but the cost will be the HT string inverter will be higher side than the central inverters. Next. Rapid shutdown system. This is the one. This is the new thing which is which will come to India in coming years or coming months. Implemented in India, which can be like in USA and other European markets and Japan and Australian markets. They have implemented thing to have the safety on DC and AC side, DC and AC both the sides. In 2000, like in USA, in 2014, NSC has made this rule to have the safety on both the sides. This rapid shutdown system is a module level power electronic microinverter. It will be installed back of the solar modules. The main application of this rapid shutdown system is uh, if there is no reference voltage or if we switch off the inverter, means the AC side will get shut down but not the DC side till the sunlight is there. There will be in one string, for example, in one string there will be like 1,000 volts of electricity which won't get off till the sun is there. The it will cause a fire hazardous, and you might have seen in the news that there had been the solar fire hazardous and such kind of things. To reduce the solar fire, this rapid shutdown system has to be implemented. This will be installed on the module level, 1:1, and this will do when there is no power in the AC side means this will shut down within 30 seconds. It will drop down to 80 volts in that string. Next slide. As I said, rapid shutdowns provides a safe way for firefighters or the solar installers to stop or reduce the voltage and current from the photovoltaic array, allowing them to perform their job safely and efficiently, like avoiding the electrical hazards. It automatically turns off reduces the voltage in the string level, and this module level rapid shutdown system comes with a safety protection device, PLC, transceiver, monitor gateway, and monitoring app. Next. Module mounting structures. It is a critical component. It will ensure the efficiency of the solar power system in both utility and the rooftop systems, and it allows the panel to rest comfortably at the right positions. That helps in maximizing the energy efficiency. In sheeted roof, we have different kinds of module mounting structures like short rail, long rail, and we can install the module mounting structure even without penetrating the sheet or damaging the sheet. And with nowadays there is a new sheet called zap block kind of sheet where we directly screw to that sheet and without damaging the sheet and mount the structures on top of it. And to the RCC roofs, we have the ballast kind of mounting and double portrait structures for utility ground mount solar. Next. And in module mounting technology, we can use the tracking system. This tracking system positions itself to the sun direction. It starts from the east and it traces the sun's position accordingly, and it increases the efficiency by 10 to 15%. There is single axis manual tracking which can be done, and automatic tracking thing, and double axis automatic tracking thing. Next. Earthing is the most important thing in the solar power systems. It will be we will earth for the modules, inverters, and all the other critical components. It is a way of transmitting any instant electricity discharge in the discharge in the equipments. It can be grounded so there won't be any hazards to the equipment or the person working over there. Next, lightning arresters. Lightning arresters, it's the most important thing. It protects and insulates the thing. Uh, Protects the insulation and conductors of the system from damaging from effects of the lightning thing. And we like consider the for example, for every like for example, hospital is a kind of a critical thing where we design with a lower radius. The utility or it's something where there won't be any much human movement. We design on the higher radius. We select on that basis. Next. Thank you. Uh, Open to take the questions if there is any. Please.
Yeah, Akshay, thank you very much for the presentation. This brings us to the end of the talk. I would like to thank everyone who attended and participated in this talk. And I would also like to request everyone, if they have any questions or queries, to send us the mail. We would be happy to answer and share the responses with you. I would also like to take this opportunity to remind everyone that we will have our fourth Tech Talk on 6th of April, and we will discuss the hybrid technology on solar and wind. We hope to see you all next time. Thank you, Akshay, and thank you all for joining us. Have a great day. Thank you.